morning, children. In the previous video we have done the concept of principle of moments, and now is the time to apply that concept. So I am there on page number 11, Selena Publishers, as we are following that book, and we are going to start with question number 10 because we have done all the previous questions. Am I right? So let's start with, they have given you the diagram. I'm just going to read out the question. The diagram given shows a uniform bar supported at the middle point O. So this is a bar being given and it is supported at the center, and this is O. A weight of 40 gram force is suspended or placed at a distance 40 centimeter. It is placed at a distance 40 centimeter to the left of point O. How can you balance the bar with a weight of 80 gram force? So from here, if you see, when I'm going to put a weight here, it's going to give me anti-clockwise moment. Am I right? Isn't it simply the case of a seesaw? When one person sits on one side of the seesaw, it's going to give you a turning effect, and it's going to give you anti-clockwise moment. Now they are asking you, how can you balance the bar with the weight of 80 gram force? Since it is giving you anti-clockwise moment, it means I need to put the weight given 80 gram force on the other side so that it gives you clockwise moment and it balances, right? It balances this clockwise moment and anti-clockwise moment. Now the question arises where to keep it. So first of all, we have 80 gram force weight is given, and let it be at a distance O from the center, right? So if we apply now principle of moments, according to principle of moments, we have W1L1 is equal to W2L2, right? So if I just substitute the values, what I'll be getting, see here, W1 is given to be 40, fine. L1 is given to be how much, the distance they have given, see here from the diagram, it is 40 from the pivot. W2 is given to be 80, and we need to find out at what distance I should place it. Let it be at a distance X, right? So it implies what I'll be getting, X is equal to 40 into 40 upon 80. Fine, this will cancel out. This is 2. This will again cancel out. It comes out to be 20 centimeter. So you can write your answer 20 centimeter from the pivot, right? Or you can say 80 gram force weight should be kept 20 centimeter towards right. So both weight is correct, right? So this is how we have done question number 10. Now we are going to start with the next question, that is 11th question. They have given, it shows a figure, shows a uniform meter rule. Since I gave you previously the instruction that whenever you read uniform meter scale, the very first your job should be to draw 0 to 100, right? And CG 50 should be marked here. And in this question actually the pivot point and the CG are same, that is 50. So let's read. A uniform meter rule placed on the fulcrum at its midpoint and having a weight of 40 gram force at the 10 centimeter mark. 40 gram force weight is being kept at 10 centimeter mark, and 20 gram weight has been put on 90 mark, right? So what is the question? Is the meter rule in equilibrium? Now how to check whether the body is in equilibrium or not? The only thing is we have learned the number of forces acting on it should give you the resultant 0, or the moment should be 0 if the body is pivoted. Now we have the second case, that is the body is pivoted. It means sum of clockwise moment should be equal to sum of anti-clockwise moment. So let me check. Now according to this is going to give me anti-clockwise moment, and this body is going to give me clockwise moment, right? So let me find out. First of all, anti-clockwise moment. It will be equal to W1L1. I'm writing here W1L1. That is 40 into, what is length here? The effective length from 50 till 10. It means 50 minus 10. I'll be getting 40 into 40. That is 1600 gram force centimeter. Fine. Now, what about clockwise moment? For clockwise moment, again we are going to use W2L2, right? And W2L2 is given by 20 into 90 minus 50. How come 90 minus 50? Because it has been placed at 90 mark and the pivot is 50, right? So what I'll be getting, again, this is 40. I'll be getting 800 gram 4 centimeter. Now just see whether clockwise moment and anti-clockwise moment are equal. No, they are not. Here, anti-clockwise moment is more than clockwise moment. So what is the answer for the first part? That this scale or this body is not in equilibrium. And what they have written, the next part is, if not, how will the rule turn? The rule is going to give you anti-clockwise moment. I have already explained you here. Second part is, how can the rule be brought in equilibrium by using an additional weight of 40 gram force? Now this is tilting, and which side it is tilting? It is tilting this side. Anti-clockwise moment is there. It means I need to put the another weight given 80 gram force on the right hand side. Okay, so what can I have here? I can write here 80 gram force, and let it be at a distance x, right? So what I'll be having? Now I'm going to apply the condition of equilibrium, right? And according to that, sum of clockwise moment should be equal to sum of anti-clockwise moment. It means, since clockwise moment is less, it means I'm going to add the additional weight this side. Fine. So I have already calculated 1600 is equal to 800 plus. Now the second weight that is added is 80, and at what distance it has been kept? It has been kept at a distance of x from the pivot. So it means I'll be getting 80x is equal to 1600 minus 800, 800. It means x is going to be 10 centimeter. Is it 10 centimeter? But 10 centimeter is here. No, I have taken distance x from the pivot, right? If it is coming out to be 10 centimeter, it means it must be at the mark 60 centimeter. So again, you have different ways to write the answer. Either you can write down the additional weight 80 gram force should be kept at a distance 10 centimeter from the pivot, or you can write down that it can be kept at a mark 60 centimeter to get the equilibrium. So I hope so this question is clear to you. Now next proceed with 13th question given in your textbook. According to 13th question, a physical balance has its arms of length 60 centimeter and 40 centimeter. Now, bache, you should not get confused that they have written a beam balance, a physical balance or a beam balance. So children get confused because it's a beam balance. So arms are supposed to be equal, right? But read the statement carefully. They have written it is one arm is 60 centimeter and the second arm is 40 centimeter, right? So I have drawn it like this is a beam balance. One arm is 60 centimeter, another arm is 40 centimeter. And then they have written what weight kept on the pan of longer arm. This is the longer arm, and let us suppose it to be W1. That let W1 is the weight on the longer arm. What weight kept on the pan of longer arm will balance an object of 100 gram force kept on the other pan. So this is the weight on the other side, on the other arm, right? I think this is a very easy question, basic question of principle of moments. The only tricky point was that the children might get confused from the statement that it's a physical balance or beam balance, right? But they have given you a condition. They have given you a condition that one arm is 60 centimeter and another arm is 40 centimeter. Fine. So from here, this is going to give me anti-clockwise moment and this is going to give me clockwise moment, right? So according to principle of moments, we have W1 L1 is equal to W2 L2, right? So let me just substitute the value. I'll be getting W1 into 60 is equal to 100 into 40. Fine. So W1 will be equal to 100, 40 and 60. So what I'll be getting, this is 2. So I'll be getting 200 upon 3 means 66.67. What are the units? We are calculating weight, right? So for weight we have gram force. So this is the answer. Now let's do question number 16. Let's try for this question. According to this question, a uniform half meter rule. So till now we were working on a uniform meter rule. Fine. But this is your uniform half meter rule. Since it is half meter rule, so I have drawn 0, 50 and the midpoint or the CG for a regular object, since it's a half meter rule. So the CG is expected to be at the center. I have marked it to be 25 centimeter. But if you read the question, a uniform half meter rule can be balanced at 29 centimeter. It means pivot point is 29. It means CG and pivot are not the same, right? In few questions they were given to be same, but it is not a necessary condition. You can fix it up somewhere else also, right? So we have 29 centimeter as the pivot point. When a mass of 20 gram is hung from its one end. Now one end, they have not specified which end, right? So is it an option that we can hang it here or we can hang it here? No, actually we don't have an option. Why? Because when it is going to be pivoted here, it means the weight, we know that CG is a point where the weight of the body is going to, it means the weight of the body is acting at the CG, but the pivot point is 29, right? So when the weight is going to act this side, it means it's going to give me anti-clockwise moment. Now when it is already giving me anti-clockwise moment, it means the scale is already tilting this side. And if I want to have an equilibrium, I have to hang that 20 gram mass on the other end. I hope so this point is clear to you, right? So 20 gram is now going to act here. Now again, a different situation. We know that in principle of moments, it is applicable for weight. W1 L1 is equal to W2 L2. We never have M1 L1 is equal to M2 L2, right? I mean to say mass is not there, it is weight of the body. If now mass is given, first of all I have to convert this mass into weight, and I hope so you know how to convert mass into weight. It will simply become 20 gram force, right? So I have converted mass into weight, and now this is going to give me clockwise moment. So now let's see how the things are going to work out. So we have, I want to check out what is the weight of this scale. Let me call it as W1, right? So I'll be having W1 into 29 minus 25 is equal to 20 into 50 minus 29, right? Fine. So what I'll be getting, see here, I'll be getting, it implies W1 into 4 is equal to 20 into, and what is here? This is going to be 21. Fine. So we'll be getting W1 is equal to, this will cancel out, 5 into 21, that is 510. This is weight, so it will become gram force. But the thing is, if you check out here, they have written on the first part of the question was draw the diagram, that we have done. Second part is find the mass of the half meter rule. They are not asking you weight. We are getting our answer in weight, but now we have to convert it into mass. As I know, weight is given by mg, which is equal to this much. So if I just want to find out mass, I need to remove this gravitational force, right? This will come out to be this and this will cancel out. I'll be getting simply 105 gram, right? So a few of you might be having a question, what is the fun that we first of all converted it in weight and then we converted it into mass again, right? We have to simply check that principle of moments is applicable for weight and not for mass. That's why we have to convert first of all it into weight, and then to get the answer we have to convert it into mass, right? So with this we finish with the questions, and I expect all of you to work out the rest of the questions. So with my wishes, I move. Take care all of you. Thank you. Bye-bye.